Okay, for this problem, we have an object that has an initial velocity of 10 meters per second being fired on a slope that's 30 degrees, but it's fired at an angle from the slope of 15 degrees. We want to find the distance L up the slope that the object travels before landing. With projectile motion problems, the first thing that we need to do is establish the equations that we're going to use. Typically for projectile motion, the best equation to use is a constant acceleration equation, knowing that our constant acceleration is gravity and is only in the y direction. This particular equation is probably the best one to use for projectile motion. Now we need to break this into parts. So we need to look at the x direction and we need to look at the y direction. In the x direction, if we use our equation here, our final position will be x. Our initial position is 0 because we started at the origin. Our initial velocity, v0, is equal to 10 times the cosine of 30 plus 15. That will give me the x direction component. And then all of that times the time is equal to my x direction. There's no acceleration in the x direction when we neglect air resistance. In the y direction, my initial position is 0. My final position is y. My initial velocity is 10 times the sine of 30 plus 15 times the time. And then my acceleration is downward, is that direction. So we're going to write this as negative 1/2. And we're in SI units. So we've got 9.81 meters per second squared for our acceleration times the time squared. So we have two equations, but we have three unknowns. We're going to need one more equation to be able to solve this problem, something to relate these two equations together. Well, we know that we have an angle of 30 degrees, and we can relate x and y to that 30 degrees by using a tangent. So the tangent of 30 degrees is equal to opposite over adjacent, which will be y over x. Therefore, y is equal to x tangent of 30. So let's go back to our equation for the y direction, and we'll plug in this for y. So x times the tangent of 30 is equal to 10 sine of 45t minus 1/2 9.81t squared. However, from this equation, we know what x is, and we can plug that into here. 10 cosine 45 tangent 30t is equal to 10 sine of 45t minus 1/2 9.81 t squared. Now we've got one equation and one unknown, and if we simplify this, on this side we'll get 4.082 t is equal to 7.071 t minus 4.905 t squared. If we collect like terms, 0 is equal to 2.989 t minus 4.905 t squared. So one solution is that t is equal to 0 if we pull a t out. Therefore, t is equal to 0, but t is also equal to 0.6093 seconds. Once we know t, we can plug that into this equation to find x, and into this equation to find y. X then is equal to 10 cosine 45 times 0.6093, which equals 4.31 meters. Now at this point, I could plug that into this equation and find y, or I can plug the time into this equation to find y. We'll just go ahead and use our constant acceleration equation and say that y is equal to 10 sine of 45 times 0.6093 minus 1/2 9.81 times 0.6093 squared. Solving that, y is equal to 2.49 meters. So we have x and we have y, but we're looking for L, which is equal to the square root of x squared plus y squared, which will be the square root of 4.31 squared plus 2.49 squared, which equals 4.97 meters. So that is our length L that we were looking for, and that ends our problem.